Afternoon, everyone. Welcome to this new regional webinar organized by the Inter-American Institute for Global Change Research, the IAI, the University of Colorado Boulder, and the World Meteorological Organization. We are pleased to announce that we have over 130 participants registered from every country in the continent. This webinar has simultaneous interpretation into English and Spanish, and you will be able to ask your questions to the speakers in the Q&A section available at the bottom of the screen. To start this activity, I would like to welcome Dr. Ana Stewart Ibarra, Executive Director of the IAI, for a few welcoming words. Thank you, Rodney. Welcome, everyone, to this second webinar on El Niño, La Niña, and the models to support operations in the Americas and globally. Rodney will be providing us with more details, but I can already tell you that this collaboration between the WMO and the IAI, the Inter-American Institute for Global Change Research, and the University of Colorado has been truly fruitful. We started meeting a year ago to talk about the regional scientific advances and how we can take this important information to the communities we serve. At the IAI, we work with 19 countries in the Americas to ensure that science is available and accessible to support decision-making processes in the area of global environmental change. This collaboration is fully aligned with the priorities of our member countries. They need to strengthen climate services, importance of climate action, and every implication of the El Niño, La Niña, and the uncertainties we have nowadays, and the scientific advances. It has been truly a pleasure to cooperate with these institutions, organizing the first meeting and now the second meeting. Hopefully, this is the beginning of a regional initiative to strengthen science and operations related to ENSO. I would like to welcome you. I hope you enjoy this webinar. We have amazing speakers that will be sharing with you scientific advances, and also we'll hear from our region's leaders in meteorological services about how we can use science to improve operations and better serve the communities we must serve more efficiently. Well, with that, I would like to give the floor to my dear colleague and friend, Rodney Martinez, WMO representative for the Caribbean, Central America, and North America. Rodney, you have the floor. Thank you, Anna. From the World Meteorological Organization, we have been working and supporting all our member countries throughout the value chain, in particular elements that have to do with climate services. This entails studying observations in every land system component through the WIGOS system, also the data processing and forecasting system, WIPS, at the WMO, also the information system at the WMO for universally exchanging data, and also global programs that research weather and climate. Together, they allow us to support our climate generations services at in every location, from the at global, regional, and local levels. And we can also, in this way, contribute to different early warning systems at different scales and provide specific climate services. In this context, the ENSO, the Southern Oscillation El Niño, is and will always be one of the essential elements of climate variability. And we have researched the phenomenon, and also thanks to the IT and technological advances throughout time, but we still need to understand its manifestation and influence in different regions and countries. Today, in this webinar, this is a new effort to resume an essential conversation between the scientific community, the climate scientific community, and our operational community of meteorological services, national meteorological services, and climate regional services. We have cooperated with the IEA and the University of Colorado Boulder. So we have organized this web seminar where we will have a renowned researcher making a scientific presentation, and then discussion panels with the valuable participation of very well recognized experts that work every day in climate service, in providing climate services at different levels. Before we start with this webinar, I would like to share with you a recap of the webinar that took place in July. If I may. Thank you. Thank you, Jose. Okay, let's set this to presentation mode. The next one, please. Last time we had a huge audience. It was almost 600 people from throughout the continent. We had the opportunity to listen to the presentation made by Dr. Lheureux from NOAA. And she told us about something that is very important for climate operational forecasting. And this is the presentation of the relative oceanic Niño index, which modifies a historically used ONI index. In her presentation, she told us about why the advantages of RONI, this relative oceanic Niño index, in particular regarding El Niño classification and its coherence with the climatology selected. She also showed the evidence regarding how this index, in particular in the El Niño region 0.4, better reflects the intensity of atmospheric indicators. We also had the contribution of Dr. Osman. She shared with us and the audience some updates about teleconnections in the IOD, in particular in South America, in particular in the spring, and also how we can better understand this if we better understand the IOD, we can improve weather forecasting, in particular during the positive phase of IOD, in particular for El Niño, but not so much for La Niña, which still has an interaction that has no linear characteristics. Then we had Dr. Pedro DiNezio, who very interestingly reviewed the consideration of El Niño forecasting and how careful we must be, in particular when we select predictors and how they can manifest in different ways and perform in different ways when we use them. Also, when he said that the heat content is a better predictor for La Niña. But in particular, when La Niña events are back-to-back, so this can increase its productivity. And he provided evidence regarding how we must be careful about climate forecasting, in particular derived from large global models. We also had the great opportunity to listen to Dr. Cristian Martinez Villalobos to talk a bit more about the coastal El Niño and to see its true extent and how we can see the lack of alignment with the coastal El Niño events and classical El Niño events that take place in the Eastern or Central Pacific. And these require very specific methods. He also showed us how difficult global models find it to simulate these coastal events. And also he talked about many considerations that we must consider when forecasting these events. And also we need to capitalize what we know about these coastal El Nino events, in particular regarding precipitation, because coastal El Nino events have a huge impact on floodings and the impacts connected with floodings in many countries. Well, regarding operations, we had representatives from the WMO. We had Dr. Cedric Van Meerbeek from the CIMH, the Caribbean Institute of Meteorology and Hydrology, who is a very important center in the region. He shared with the audience a number of recommendations and lessons learned that have allowed them to improve their forecasting. He also shared forecasting, impact-based forecasting, which has increased user trust, reduced uncertainty levels, and properly communicate forecasting to a larger audience and not necessarily to a specialized. Felipe Costa, the CIFEN director, also shared with us what they're doing in South America regarding ENSO patterns detection using computational geometry techniques. They are doing this in the west of South America, but they want to go from a regional to a global scale regarding El Niño. And they have been addressing several seasonal and sub-seasonal techniques using satellite data and combining this information with social and economic impacts. From the also we had the Laura Aldeco from the Meteorological Service of Argentina. She talked about the advances on different scales regarding forecasting, but also challenges communicating ENSO events. Sometimes there is no agreement or some contradictions between global models and what is observed in a given country and how this uncertainty can be handled given the lack of consensus in the region. But also, at the SMN, they talk about how important it has been to strengthen the partnership between the academia and the meteorological service, because this has allowed them to combine scientific advances, the team working with the operations, and it has also allowed them to gradually include other predictions and other interaction modes, such as the IOD and other indices in the Atlantic. The next one, please. Well, thank you so much. So this was a brief summary.
I'm pleased to introduce to our keynote speaker, Dr. Shang-Ping here. He is a world-leading climate scientist whose work has profoundly advanced our understanding of ocean-atmosphere interactions and the Indo-Pacific in the Indo-Pacific climate system. His research spans a remarkable broad spectrum from foundational theoretical insights to cutting-edge prediction and modeling efforts with clear societal relevance. We are really pleased to have you here in this regional activity. Dr. Shang, welcome. The floor is yours.
Oh, thank you very much. So let me share my slide. Okay. Okay, that should be okay. Okay, yeah, thank you very much for the invitation to speak here at this seminar. So today, it's my privilege, to be the speaker of the gathering. So today, I would like to talk a little bit about our recent work to kind of understand the dynamics of 2023 El Nino, and maybe I will not have time, but I certainly would like to discuss, the implications for predictability, maybe in a discussion. So 2023 is really a busy year for climate events. So it started with coastal El Nino event off the coast of Peru, causing rainstorms and windstorms. And then, in the summer, it became the hottest year on record at that point. And then exactly kind of just following the coastal Peruvian coastal El Nino, there was a basin scale El Nino that developed into quite strong event by the measure of Nino 3.4 sea surface temperature anomalies. But with another measure, such as southern oscillation, I don't think 2023 was that strong, as I will kind of highlight in a bit. The key here, I guess the previous speaker kind of spoke about, the scientific triumph, kind of to understand El Nino as a couple ocean atmosphere phenomena, and therefore leading to the successful prediction of El Nino southern oscillation these days. But I guess 2023 gives us example, real example that sometimes the Nino 3.4 SST anomalies may not go that hand to hand by hand, kind of a close relationship with the southern oscillation. So that is in a sense a summary of my talk. So I guess here I'm showing the sea surface temperature anomalies for June, July, August 2023. As you can see, there's people would call Eastern Pacific El Nino developing in the equatorial Pacific Ocean. So that is kind of a culprit to the record warm global surface temperatures. And then at the same time, maybe a slightly smaller in magnitude of sea surface temperature anomalies, but certainly in terms of standard deviation of the region in the North Tropical Atlantic. So the sea surface temperature there was extremely strong and associated with weakened northeast trade winds. And then this tropical North Atlantic warming has important consequences. Like during a typical El Nino, usually the North Atlantic hurricane count, tropical cyclone count would decrease, right? There would be fewer tropical cyclones in the Atlantic basin during El Nino, but not in 2023. In 2023, Atlantic had 20 tropical cyclones in comparison with 13 in the Western North Pacific. So there clearly, this warming in the tropical North Atlantic has influence, at least in the same basin of the North Atlantic. But our study will show this actually has impact on the developing El Nino in the tropical Pacific. So let's come back to focus on the tropical equatorial Pacific, the El Nino itself. As you might notice within this area, right? So usually we expect the westerly wind anomalies to develop together with the growing El Nino during this time of year. But during the summer of 2023, there were very little westerly wind anomalies. So to the extent that the westerly wind anomalies is a manifestation of the southern oscillation. So this would be a strong El Nino, but without a southern oscillation. So it's a little weird, right? Because ENSO these days is taken to highlight the coupled nature of El Nino southern oscillation. So our question, that raises a question, why there were not much zonal wind anomalies despite a growing El Nino in the equatorial Pacific Ocean. So that is the first question we want to address. So in order to address this question, we actually utilized a global atmosphere model, and then we would like to invest. This is the model simulation for June, the second half of 2023. So you see like a El Nino warming and persistent tropical North Atlantic warming as well. But the equatorial westerly wind anomalies were weak. So this is model simulation kind of reproduced largely observed wind anomalies using this atmosphere general circulation model. And then, we would like to kind of ask, why this zonal wind in the Western Pacific are so weak. So we divide basically the total sea surface temperature anomalies into a long-term trend, right? 40-year trend. And then on top of that, we want to study detrended sea surface temperature anomalies in the Pacific Ocean, right? And then we want to study the Indo-Atlantic Basin SSC anomalies because, as we have emphasized, in the North Atlantic, there's tropical warming, whereas in the Indian Ocean, there's the Indian Ocean dipole, you might call the Indian Ocean Nino, right? Also kind of a developing, maybe Nina in this case, developing in the tropical Atlantic. So by using this atmosphere model, we can decompose various components of sea surface temperature anomalies and evaluate their contributions to the equatorial wind anomalies in the Western Pacific. So it's very clear, the warming trend, long-term trend features a La Nina-like pattern. I think Pedro and others are intensively studying this phenomena. So in other words, the long-term trend features accelerated trade winds, and also the Indo-Atlantic Ocean basin contribute to the further intensification of the trade wind. So those intensified trade winds are not favorable for El Nino development. So usually, given these conditions, people would say, El Nino is unlikely to develop. But I guess, if we kind of focus on the sea surface temperature anomalies in the tropical ocean basin, then, this is a very typical El Nino. You have a southern oscillation producing this westerly wind anomalies that are coupled with the equatorial Pacific warming and grow by the Bjelken's feedback, right? So this panel clearly kind of gives us some comfort. This is really an ENSO phenomena. But the reason the zonal wind anomalies are weak because there are other components of SSC anomalies, in particular the tropical North Atlantic warming and the La Nina-like long-term trend. So that is like a meteorological problem, right? So in a sense, we solved the meteorological problem. Why winds are such during this the growth of this strong El Nino event. And then I guess just to kind of drive this point home, right? So we can scatter Nino 3 sea surface temperature anomaly with the Southern Oscillation Index, in this case, the Western Pacific 10-meter zonal wind. And then, the past 40 some years data points are forming, indicating to us there's a strong correlation between El Nino and the Southern Oscillation, except 2023. So 2023 is an outlier. The Nino 3 SST amounts to like 2 degrees Celsius in this plot. But the Southern Oscillation is probably on the margin of 1 standard deviation, maybe even below 1 standard deviation. So that raises oceanographic question, right? So how does El Nino even develop without a strong feedback from westerly winds, right? So that is oceanographic problem. I'm going to spend maybe the next 5-10 minutes to talk about this. So given to address this question, we took a drastic measure by stopping the wind anomalies altogether globally from April 1, 2023, and see what happens, right? So in other words, we ask a question, if we stop the wind anomalies, maybe this El Nino won't develop, right? So that might be something, at least some people would think. So in order to do that, we need an appropriate tool to do the numerical experiments. So you might think ocean general circulation model can do the job. Yeah, to some extent, as simulation tool, right? So, but when you want to do drastic experiments, such as stopping wind anomalies globally, right? Your sea surface temperatures are expected to deviate from observations a lot. But in the ocean general circulation model, the setup is you have to supply air temperature at the surface, air humidity at the surface. That is not going to be compatible with your experiment results, right? So because, in a sense, the ocean has large thermal inertial and slow time scale. So it's physically, it's the SST variations driving the variations in air temperature, air humidity, not the other way around. So to kind of solve this problem, these days it's not that expensive to run a coupled ocean atmosphere general circulation model. So in this case, we are going to prescribe the wind stress from observations and apply that observed wind stress to the ocean general circulation model. So in that sense, the winds are going to drive El Nino Southern Oscillation. But we don't do anything on air temperature, air humidity, and we let the atmosphere model to figure out how the air temperature, air humidity should be, right? So in that way, this is more physically consistent model to simulate and to do experiments on El Nino and tropical Pacific sea surface temperature in particular. So this is the comparison with observation in black, and the simulation is in red. So in this wind stress paced couple model simulation, the sea surface temperature in Nino 3.4 matches observations almost 1-to-1, right? So the correlation amounts to like something like a 0.93. And then so there are a couple other benefits. I'm not going to too much here, but a major point is this is a physically consistent system, numerical system that we can use to simulate El Nino with observed wind stress. Okay, so this is a Hoff-Muller diagram of sea surface temperature in color contours and the surface wind anomalies during year of 2023. So 2023 was preceded by basin-wide La Nina event. And then the winds calmed down kind of in April largely. And then you see like the sea surface temperature develop, the growth, so rapid growth of positive sea surface temperature anomalies, accompanied by very weak westerly wind anomalies compared to, the November, right? The winds anomalies very strong. But during much of the growth period of 2023 El Nino, the wind anomalies are quite weak. So we did a simulation of a Nino 3 SST, right? So the black line is the simulation result. So it of course, it successfully captured the sea surface temperature anomaly, the positive growth of sea surface temperature anomalies. And then we did an experiment. On April 1, we stopped the wind anomalies altogether globally, right? So everywhere the winds are replaced with long-term climatology. So surprise, when we suppress the wind, the sea surface temperature anomaly in Nino 3 region kind of closely kind of follows observations, all the way to October. Maybe from October it starts to deviate, kind of maybe decay too fast. Whereas the wind feedback, the Bjelke's feedback kind of picked up toward the end of 2023. And then the difference, the control simulation versus no wind stress anomaly experiment, the difference can be taken as the effect of zonal wind SST feedback, so-called Bjelke's feedback in the tropical Pacific Ocean. So this is weird, right? Because without wind stress anomalies, this El Nino developed anyway. So you might think my model might be something wrong, right? So I just show you, our model simulation of the other three major El Nino events, 82, 97, and 2015. And then in that model, when we stop the wind, right? So the SST, the growth of El Nino, is very, very weak, and it falls back to zero sea surface temperature anomalies. So it's clear in other major El Ninos, the zonal wind feedback is essential for El Nino growth. But something weird, unique happened in 2023. So what happened is, because the 2023 was preceded by 3 consecutive years of La Nina, so the strong enhanced easterly trade winds in the equatorial Pacific kind of keep piling warm water, ocean warm water in the western tropical Pacific Ocean. So the color shading here is the sea surface height, right? Sea level anomalies. So that is basically measuring the thickness of warm water in the tropical ocean. So when you see like a red region, that means the thermocline deepened a lot, whereas the blue color means showing the thermocline is shallow, and it might be hard for you to see, but they are like a pink or maybe purple line contours, right? So those line contours are the sea surface temperature anomalies. So during January, February, March of 2023, El Nino was decaying rapidly, but you still can see a shadow of La Nina, right? So La Nina, the 3-year La Nina piping up a lot of warm water, deep thermocline in the Western Pacific Ocean. And then this is the time of the year, right? So before we manipulate the zonal wind. So this is April, May, June average of ocean temperature anomalies across the equatorial Pacific Ocean. So here is the coast of Asia, and here is the coast of Central America, South America. So this basically shows the thermocline is these two lines. So I guess the black line is the thermocline in the April, May, June season of 2023. So in other words, when we stopped the wind, or maybe in nature the winds weakened from April onwards, right? Because the influence from Indo-Atlantic basin, and because the La Nina-like trend pattern keeps the trade winds strong, at least not weaken. So, but when you stop the easterly wind anomalies associated with the previous La Nina, then the positive ocean heat content anomalies in the Western Pacific will kind of rush back in accordance to ocean wave dynamics. In this case, the equator is like waveguide for this Kelvin wave. So Kelvin wave is like a warm water kind of a push on the coast of Asia, and when you stop the wind, then the warm water would rush back, right, flush back toward Ecuador. So that is the observation basically captured this downwelling of warm Kelvin wave that kind of sent the warm water back to the coast of Ecuador. And then in July, August, September season of 2023, the color shading again is the sea level anomalies. So you see this remnant of warm Kelvin wave still lingering on the coast in the eastern equatorial Pacific Ocean. And the line contour, the purple color, indicates the sea surface temperature anomalies. So basically, the deepening of the thermocline in the eastern equatorial Pacific creates strong sea surface temperature anomalies in the eastern equatorial Pacific. So that is, the story of 2023. So basically, it developed without much help from the zonal wind anomalies in the equatorial Pacific Ocean. But it was helped by the long-lasting La Nina preceded this strong El Nino event. So here is just a summary, right? So I just repeat, I would say that 2023 is strong basin scale El Nino, but with very weak zonal wind feedback, because the influence of Indo-Atlantic sea surface temperature warming that keeps the trade wind strong. Whereas, the other major result of our study is we developed a modeling tool, right, to use the couple general circulation model, force the ocean component of that model with observed wind stress. That allows us to simulate El Nino very, very well. And that allows us to quantify the two important factors for 2023 El Nino, namely the concurrent Pacific wind feedback or the initial ocean conditions at the end of the preceding La Nina event. And after you have heard my talk and see my results, you have to conclude, El Nino is no longer a tropical Pacific phenomenon. It's a trans-basin phenomenon influenced by trans-basin interaction. So that is maybe a message I want you to take home. In other words, when we predict El Nino, of course we need to focus on the Pacific, but sometimes the other ocean basins could influence the coupled interactions in the Pacific basin, just because ocean is separated into basins, but atmosphere is not. Yeah. So that is, yeah. I'm happy that I'll stop here. I'm happy to take any questions.
Thank you very much, Dr. Shang-Ping, for your excellent presentation and your final message, which is very useful for the community that is working in seasonal in climate prediction. The need to focus on the ocean, Pacific Ocean as usual, but also putting a lot of attention in other bases like the Indian Ocean or the Atlantic Ocean. So this is very important, and we continue advancing with the research to understand this interaction, interbasin interactions, very, very useful. So if you have questions, please send them in the chat, in the question and answers section, in order that Dr. Shang-Ping can respond you by the chat. A continuación, a continuación en esta actividad,
Now,
como ha sido el propósito, como fue el propósito de este webinar, es combinar todas.
The aim of this webinar is to combine all these scientific inputs with what is happening in many of our member countries. After the last webinar, we need to better understand how global forecasting for ENSO is taking place, and also how this is being implemented nationally, because we need to understand country experiences when it comes to using the available information at different scales and providing the best information services possible within their countries. So we have a first panel. We have the privilege of having Engineer Jacqueline Rivera, General Director of the Observatory of Natural Resources and the Environment in El Salvador, and Dr. Pedro, scientist from the University of Colorado. They will be talking about their countries and how they are using this information. Let's have a round of 8-minute presentations then. We would like to start by inviting Jacqueline so that she can start with her presentation. Welcome, Jacqueline. Good morning, Rodney. Thank you so much. Good afternoon as well, if you're somewhere else in the world. First of all, I would like to, let me just give me a second so I can share my screen. Rodney, can you help me?
Please stop sharing your screen.
Okay.
Thank you. Para comenzar un poco con la introducción al respecto de cómo estamos haciendo
So, I would like to talk about how we are using ENSO tools in El Salvador. So, I would like to, can you please confirm, Rodney, if you can see my screen? Yes. We can see your screen. Okay. This ENSO information that we use within El Salvador in our operational annual operational planning activities, and not just annually, but we work with 3-year forecasting as well. And this allows us to contribute to decision making. In particular, because within El Salvador and our Observatory of Threats and Natural Resources, in 2016, we implemented an impact-based forecasting and information service. In this sense, we have detected that in order to implement impact-based forecasting, we need scientific knowledge to be should have the highest time, space, resolution, with a wide historical range in the data, but with very recent data as well. In this sense, we have realized that scientific knowledge is helping us create actions that will promote preparedness. In this sense, and this type of research that we have seen, because we aim to improve time resolution, spatial resolution regarding ENSO forecasting, so that we have a strong basis to implement impact-based forecasting information. But this information within the observatory and within the El Salvador context is something that is also used by the civil protection system, and this allows us to create an observatory that aids decision making. In this regard, if we know about ENSO, we can improve processes and the preparation of the national monitoring system in El Salvador. This also helps us get ready to prepare this long-term forecasting information, sometimes over a year, because we do quarterly forecasting, so that the national civil protection system can have this information and get ready. And these scenarios, potential scenarios, are droughts, extreme meteorological events. There's also landslides, or we include also in the observatory landslides, floods, also the need to prepare when there are heat events or heat waves. So this quality information with better time and spatial resolution allows us to see the strategic importance of ENSO forecasting in the country. So as a country and as a region, there is high sensitivity to climate conditions, sudden changes, and also what happens with rains and temperatures. And these changes and effects are directly related to the impacts on culture, energy, water, and risk management. So we say that ENSO is actually a major key factor to anticipating and preparing for impacts. Therefore, this kind of forecast is essential when it comes to climate change management. We do this when we work with risk matrix. A risk matrix. It's important to know about exposure and vulnerability in some national spaces, yes. But also we need to improve our forecasting models, because here we also include the uncertainty within the process in which we determine short or long-term perspectives. In this sense, in the observatory, we also use every tool and approach through an early warning system. This is the structural framework that allows us as an observatory to work in a coordinated manner and to identify which are our contributions regarding monitoring and forecasting, yes, of course, and regarding science, but also how this information that we are producing operationally allows us to reach the population and decision makers. In this sense, we need to have tools that create better resolution information, both regarding time, space, and we should be able to do this through scientific knowledge in order to improve information dissemination. We communicate information through newsletters, special reports addressed to decision makers for responding, but also we organize community roundtables and institutional users fora that include the sectors of agriculture, water, electricity. This information is essential for preparedness and response, and also for contingency plans with communities. Within early warning systems, numerical forecasts, they can be based on weather, hydrological, climate, forecasting, etc. They better allow us to define thresholds. And this then allows us to improve forecasting and impact-based information and this in turn improves dissemination, response, and preparedness and coordination. This includes what the observatory does, but also what we know nowadays as the civil protection system. In other countries, this is called the civil defense system. This also allows us to improve what we do with thresholds, climate and weather forecasting as well, in order to contribute to the anticipatory actions, and which are also an approach we are implementing. And also, ENSO forecasting contributes to the main topic that gives rise to this information for decision-making and preparedness. Well, I know we don't have much time, so I would like to end by saying that this focuses on the following reflection. What can we say about this call to create information for the population? We need to design our monitoring, forecasting, preparedness systems, our risk management systems. We need to create that considering how the human mind needs tools for decision making. And it's a huge challenge because our users come from multiple disciplines. These are the community as such, also electricity generation, agriculture, etc. And we have many users that use this information and need us to translate these huge scientific forecasting efforts regionally and globally to information that is relevant for accurate and informed decision making. Therefore, all our climate and meteorological services are working really very hard and they want to improve their forecasting. And this is a key, an essential point in order to contribute to anticipatory actions, anticipatory planning, improving risk management, and making our communication more effective, because that also helps us be ready. In El Salvador, let's remember that one of the challenges that we have, there might be many difficulties regarding resolutions and forecasting, but we have implemented impact-based forecasting. And we have managed to create these interinstitutional debate panels, which produce a lot of basic information for governmental institutions to make decisions regarding preparedness. Thank you so much for this opportunity. Hopefully, Rodney, this short presentation has been very clear about how these forecasting tools allow us to improve the information we provide as meteorological, hydrological services. Thank you, Jacqueline. Of course, very good recommendations. And also, we have information about what the El Salvador Observatory is doing. It's one of the leading countries regarding this new way to present climate and weather forecasts, now impact-based, so that they can actually have an impact on decision making. Thank you so much, Jacqueline. Let's check that we have our colleague Julieta Serna from IDEAM here. If you're here, please, you can start your presentation on behalf of IDEAM. If she's not here, let's wait for her, and let's invite Dr. Pedro DiNezio to make his presentation in this panel. Thank you. Thank you, Rodney. So I'm not using any slides. I would like to share my dual experience because I've been a researcher in the United States, you know, hardcore research of the El Niño dynamics and also if it can be forecast or not. And also my work as an activist in Argentina to bring forecasting to final users. And I think I have included everything in my work. Mechanisms to share information. Last year, I organized a working group on agroclimate in the province of Buenos Aires, in a very important agricultural region in Argentina, and I was born there. So I exist in both worlds. So I want to share with you now, given that we are so many people, 425 people right now, I would like to let you know that I'm very interested in these topics, so please let me know if you want to share with me any kind of opinion. You can include questions in the chat. It happens quite often to me when I talk about El Niño that all of us are waiting for these canonical responses, and we have composites or averages of what El Niño should be. But in the last 10 years, we have learned as scientists and also people in the territories, we have learned that all El Niño, La Niña events are different. Shang-Ping's talk was very clear. The 2023 El Niño had a very different dynamic. It seemed to be very intense, very similar to 2015, 1997, and 83. However, it did not, the impact was not that strongly felt. So in the last 10 years, I've had this concern. Do we have the right models, the ocean atmosphere models, to start the forecasting? Do they have the necessary dynamics? If you consider what Shang-Ping said, there is this tendency, because we have the model, but does the model have the necessary trend, that cooling pattern with more intense winds? This is what happens in El Niño events, and it's favoring the persistence of El Niño events. Do we have models that simulate that with the necessary accuracy to simulate events like the one just described by Shang-Ping? I was just asking that in the chat. Maybe Shang-Ping can answer that. So from there, teleconnections with other oceans. Do we have a forecasting system that simulates all those global interactions? The equatorial Pacific, the interaction with the tens of external drivers, and interaction with the other oceans. And if you're in South America, in the Southern Cone, in the province of Buenos Aires, which is a very important agricultural area, there's also the Southern Hemisphere effect, the SAM. For instance, this spring, which will end on the 21st of December, in the central region of Argentina, we've had a very rainy spring, and we were expecting a drought because we're under El Niño conditions. And we have droughts during La Niña, and we've had truly traumatizing El Niñas in Argentina. This year we were lucky because it rained heavily. But the forecasts were wrong, and awfully wrong, because we were expecting droughts and we're getting record precipitation levels. So we have that problem. What went wrong this year? Was it a problem with models? Was it uncertainty of processes that we did not include in the forecasts? Our models, do they not work? Or just a suggestion for national services? I think we need to start thinking about in a way, I'm trying to find the word in Spanish, but it's like a post-mortem test, an autopsy. Yes, that's what we need. We need to perform an autopsy of what happened and why this year, in this case in particular, this happened. And this is when we bring together science and operations, because we need to implement all the scientific knowledge we have with the level of detail as explained by Shang-Ping in an event that is so similar, but yet different. And this year it's La Niña. I'm strictly talking about the Central East region of Argentina, Uruguay, and Brazil, where we have droughts during La Niña. But this year it rained a lot. So what happened? We need to understand this retrospectively. We need to have the feedback with the models, the dynamics, the theory, and we cannot wait for this to be done in central countries, because central countries do that, but for their region. In the States, when the forecast fails, they study why the forecasting failed, for instance, in California, but they don't care about the forecasting failing in the Southern Cone. So that's my first recommendation. We shouldn't take global forecasting as the absolute truth, in particular in our regions. And we need to be more involved. And the objective of this webinar, and I'm part of, I co-organized it, is to have this conversation and to come up with mechanisms so that we all participate in science, and also so that all scientists participate in communicating forecasts, because we need to learn. It's very difficult to communicate this type of forecasting. And I always tell this to users, forecasting El Niño is so much harder than forecasting meteorological weather, because it takes every 3 or 4 years, and we learn something new every 3 or 4 years. With meteorology, you learn something new every week. There's an extreme event, you study, you try to see what happened with models or forecasting. Here we need to wait 4 years to learn something new. And what Shang-Ping has learned, what the 25-26 week El Niño event is telling us, and its impact, deviating from canonical impacts or not, these are all learning opportunities. And this continuum of scientific, technical, and operational interaction in every country or impacted region or country. It's very important to keep this in mind in order to do research, and so that this is considered when we develop new models. And maybe one day soon we'll have our own forecasting adapted to our regions with better resolution, as Jacqueline was saying, with the resolution we need.
And thinking of having more participatory processes for designing all of these mechanisms, and having science working in our sector, in our parts of the world, and having everyone involved, from the users of these services. And so that's so far what I wanted to share. Thank you so much, Pedro. These are some reflections, and experience shows us that when we think we understand a lot of things about El Niño, there are always new things, and so we need to be continuously learning and researching, and this is so important work to be able to serve citizens and help governments. And now I have the pleasure of inviting Julieta Serna, coordinator of the meteorology team at IDEAM Colombia. Welcome, thank you, Ronnie. I would like to also give the compliments of the directors of IDEAM. Unfortunately, they're at a different event, and so they're not able to attend.
Listo, y de acuerdo con el tiempo, les queríamos mostrar
and so we wanted to show you the progress in research with the ENSO phenomena, and it's very interesting what has been discussed so far about the 2023 El Niño event and everything that has been described after we went into a neutral position and with the colder ocean, because this weather system is posing a challenge for us also in the context of global warming of oceans. And so these averages and these likely conditions that we have identified in the past are changing. And so this is always an invitation for our analysis to keep improving. I wanted to discuss how in Colombia we have made some progress in research, and we have a breaking point of this analysis between different indicators that are usually used by weather services, and also how we work with this information. First, we need to take into account that the results that all services seek by delivering information for citizens in general to make decisions, but also to governments. For a few years, we have had staff limitations. And so some of the advances may be delayed or slowed down by the lack of adequate human resources. So I would like to issue a call for us to to strengthen our services in all countries, not just in Colombia. And so the institutional model had some results in 2010, and then it was updated in 2014. And it's important to tell you about it because it used to deal with different categories, and it had as a reference the El Niño 3. And so there was the behavior that was identified for the Pacific, was rainfall, temperatures. And so at the time, this indicator that had based categories weak, moderate, and strong. And as mentioned by other meteorological services, we communicated this throughout the country through maps, newsletters, and so that citizens and different organizations can also combine this with specific information for each of the economic area or industry and what these weather variations may mean for them. In Colombia, when we talk about this, indicators in this central area and also in El Niño 3, we have a bigger correlation, a more notable effect for rainfall in the northern and central parts of the country, but also these cooling patterns that are specified in the central or western basin show us effects in other parts of the country, such as the eastern part. And so we are increasing or scaling up our research to show the different specific responses throughout the territory, because we have different patterns of cooling and warming in the ocean. And also in Colombia, temperature does have a generalized effect throughout the territory, unlike what happens with rainfall. And so these results are part of what we communicate in different sessions with associations and also in our newsletters. And we have the typical averages of what happens with these extreme NOs. And what I wanted to stress for Colombia is that when we have intense cooling or heating, we have La Niña shown in this case. When it's categorized as weak, we have had significant impact on rainfall. And so this shows that the severity of the cooling or heating is not directly correlated to weather variations, and along with other different analysis and other variations, other variables that need to be taken into account. And recently we have a publication on climate variability that we did jointly with the Weather Alliance, the Climate Alliance, sorry, and it shows some inter-decade indicators. And we have different results that are available and are part of the basic guidelines for decision making. But after moving on from El Niño 3, we have done the follow-up with using the ONI index. And we have had 24 El Niño events using that indicator since 1950 and 20 La Niña. But it should be noted that La Niña tends to be longer in time, and this information also helps us review and work with each industry, with each sector, to help them with making decisions depending on the effects that this phenomena may have. As for communication, we have been working at improving this because waiting until these events take place is not good. You know, the people want to have the information ahead. And so we would indicate if there's only ocean alterations, we communicate that. If there are atmospheric alterations, we indicate whether it's a Niña type or Niño type phenomenon. And then this is something to be taken into account for forecasting, and we also consider possible interactions with other phenomena because we may have a prevalence of a series of conditions. And so in general, with communication, we have these trimesters for 2024, 2025, with Niña type conditions that didn't end up being La Niña, and then because of conditions. And we have also made analog analysis to show the scenarios we have had, and as the results for rainfall in 2023, which were already discussed today, we have the behavior that continued after these strong events. So to show the recent behavior and what follows those events, what the rainfall was like in those times. And what is notable is that it was different in some cases, and those conditions that are thought to be more likely, we need to have shorter term observations to see what is typical for those events to develop. And something to tell you quickly is that we have better information, we have this climatology with better data. And what we have found is that what has happened in the country with either El Niño or La Niña events, and the La Niña is the one that has the most notable effects, and so we need to prioritize learning about these conditions. We also have this classification into weak, moderate, and strong, and we see that La Niña has a more significant effect, but what is notable is that the weaker ones can have the higher effect regarding rainfall. And so, as mentioned, we will soon publish this effect on glaciers because we have had a significant loss of glacier area with the last El Niño. You can see in the pictures very graphically the reality of what is happening. And we also have progress as for the economy. We have some results of the impact of the extreme phases of ENOs. And so we have the effects of rainfall on the cattle raising sector, but that can be good for them. But for example, for fishery and for water, drink, sanitation is a problem. And so that was what I wanted to tell you. Thank you so much for inviting me, because it's really important to share about the follow-up that we do and how the dynamics of these phenomena have been changing within the context of global warming. Thank you so much. Thank you so much, Julieta. It's really important to look at this dimension of communication as well, how you communicate the impacts of El Niño. And also at the beginning, we shared the summary of the previous webinar the challenges that we are going to have in the future because of the discontinuation of the ONI index, and there's a new index coming soon. And so in the region, we're going to have to discuss and decide, are we going to continue to use the one that is going to be discontinued soon, or are we going to use the relative ONI, which is a change that NOAA is promoting? And so in the next year, we hope to have a discussion session with NOAA, with people who are interested, with the meteorology services of the region, to continue this discussion and to look at the operational implications of this. So thank you so much to all the participants in this panel. We have seen the national dimension of dealing with the information about El Niño. And to continue with this webinar, we go into something that a lot of people asked for after the first webinar. So how does this information translate to the weather services, the key sectors? And so for that, we need to acknowledge that in the last 30 years, we have made significant progress. And thanks to that, we can speak of sectoral weather services that are operational, that have shown favorable evolution. And so in this webinar, we want to share the experience of some experts to show what has been happening with the provision of weather services in different sectors. And for that, we have engineer Irene Trebejo from SENAMHI from Peru, with a lot of experience on weather services. Dr. Paulo Ortiz from INSMET in Cuba, also very experienced in weather services and the production of tools and working in the interaction between weather and health. And Berny Fallas from Báez, Costa Rica, who co-chairs the hydrology panel of the Region 4 Association, and he's here to tell us about the weather services for the energy sector. And so each of the panel members will have a maximum of 8 minutes, and we have Irene, you have the floor. Thank you, Rodney. Good afternoon, everyone. Hello from the Meteorology and Hydrology Service of Peru. I'm going to share my screen. I'm not able to share it. Oh, there we go. Can you see my presentation? Yes. Great. Okay, good afternoon. So as a sectoral weather services that uses ENSO information for decision making, I'm going to briefly show you the services that we provide for agriculture. As you know, ENSO is the main source of predictability for weather parameters in Peru. For a warm event, we have severe rainfall in the coastal and northern areas. In general, for cooler events for like La Niña, we have increased rainfall in the Andes and other cool weather phenomena. And so we can see that these are very important tools for decision makers. For weather services, we work 3 months periods, and we now work in monthly forecasts. And in the last year, we are working also with weekly forecasts. And so this tool is very important input for the intersectoral committee that works on El Niño, and from atmospheric analysis and other elements, we prepare this communication that is issued monthly that follows on this El Niño phenomena. And so we have alerts for this sector for the different phenomena and conditions that may take place and what actions they may want to take for disaster management, for the healthcare sector, for agriculture, for transportation, and others. And so we work with the Ministry of Agriculture for the framework for different for different crops. And so for these services, we have the service provided. These services are tailored by working together with users, and so that they are useful for decision making for them. And so we are adding value here. And so we start with the mapping of stakeholders, then we map the needs for information they have that each stakeholder has. We also assess the services, the supply of services. If the ones that are already available are not enough, we adjust what is existing, and we make sure that they can understand the information and use it. And so we have services both at the national, regional, and local levels. And now we're going to continue with our experience from starting in 2016 because of some issues with water, some deficits. And we have been doing these services by providing information on weather conditions, about specifically water, and the people working in public institutions that have to do with water management. And so far we have over 320 users in the platform, and it's done monthly.
This climate service has already been acknowledged since 2024 in its good practices regarding public management. Another experience regionally within climate services and within the Andes project, we have worked with 2 services for the San Martin region. This region is located in the Amazonian region of Peru. There's a service that we've been sharing with the Ministry for Agriculture regarding the transfer of climate risk. We are working with an indexed insurance for the Department of San Martin based on climate, because most problems have to do with precipitation, so flooding, etc. So we work for this context, for this region, by analyzing meteorological variables, which variables are conditioning the different problems that take place. So what causes the issues, first of all, and also which are the thresholds of climate variability. So that's what we're doing now. We're researching with the sector so that this product is considered as an indexed insurance policy. And they need to be evidence-based and activate automatic payments according to what has been established. So this is one of the services we are developing. Another product that has already been implemented, it started operating in 2023. It's the Agricultural and Climate Technical Group for the San Martin region. It includes producers, people from the agricultural sector, private sector, the public sector, the academia, but what's most important about it is the articulation of meteorological services as information provider to many users. We have users in the agricultural sector, the SENAMHI, the regional government, etc. So these are interdisciplinary teams. These are interinstitutional and intersectoral work. So this technical team meet, they prepare a technical document called the newsletter of the climate group. It includes a climate forecasting for the region, quarterly forecasting as well. And this is used to issue several technical recommendations, plant health recommendations as well, in order to strengthen the capacities to adapt to climate risks, variability, etc. This document has started being presented in 2023. We already have 14 newsletters. This initiative has been recognized by the regional government. We've also worked with capacity building. Over 900 producers have been trained. We also held, we've also trained the staff. Also, we work locally with our climate services. We have the agricultural and climate platforms. They are called PGA in Spanish. They are very used in different districts. To date, we have 4 platforms, but others are being built. One of the first ones is in the Motupe on the coast of Peru. The following one, Apata in the center of Peru, then Quiquijane on the hills in Cusco, and Ácora de la Suena in Puno. So we have 4 platforms that are implemented for managing agriculture and the weather. Finally, as a local climate service proposal, we have the Community Agro-Climate Technical Group, which is located in the Rimac River Basin. It articulates the work of different agencies, in this case, the Cuadrochiri Agency, SENASA, AgroRural, SENAMHI. Also, in this case, the scope is local. We work with different crops, for instance, avocado. And we work with different farmers and for different stages of the crops in order to help the technical team and the farmers. Our last experience regarding has to do with the weekly forecasting. We do this with native communities in the Amazon region and in Copasacha. the Amazon, Cobalsacha, the Amazonian region in San Martin. We issue weekly forecasts, and we trained a group of around 100 inhabitants in the community, native inhabitants, and also senior year high school students, so that they understand the forecast, and we have also taught them a lot of meteorological terms so that they can understand the information and use it. And even some services are produced in native languages. This is a very important experience because it allows us to work at different levels, local, national, and regional levels. So these are most of the experiences that we've been working on in the last few years. So thank you very much for this opportunity. And also we would like to highlight and thank the leadership of SENAMHI in the last few years in improving climate services. And this has been possible thanks to the participation and empowerment of the agriculture sector, in particular the Agriculture Ministry and its agencies. This has allowed SENAMHI to get closer to users, to create information, and to develop customized products so that users can understand climate change variability. Thank you so much, Irene. Your presentation shows something that started many years ago, and these are the agricultural teams or mesas agroclimáticas, agricultural and climate focused. And Peru has been able to strengthen this interface with agriculture, farmers, and rural communities as well, even in their own languages sometimes. And this started many years ago, this concept of sector-specific climate groups. This type of initiative is very much promoted in the region. The WMO also supports this because they're like a new version of regional or national climate fora. But this interface is now stronger, and it is taking the complexity of seasonal climate forecasting to a community that really needs climate information. So this is clearly a success story that should encourage us to move forward, because what Peru is doing is also taking place in other parts of America. In Central America, there are many well-established groups of this kind as well. And it's great to see this happening in the institutions, and it also has the support of different government agencies. Thank you so much, Irene. Now we would like to invite Paulo Ortiz so that he can share his experience, rich experience in climate services in the health sector, which is very important for the entire region. Welcome, Paulo. Thank you, Rodney, for the introduction. Thank you to the university for allowing us to participate. And without further ado, Ana, can you please display the slides so that we can save time?
Ok, a la primera, Ana, exactamente, a la primera. Muchas gracias.
Thank you so much, Ana. Yes, okay. Well, without further ado, now I would like to talk about our experience and an example of what is now being done in applying climate forecasting, and in particular El Niño event forecasting in the human health sector. It's good, we must highlight that in order to understand. Can you hear me okay? Okay, to understand the effects of El Niño, we need to go through the impact of global impacts of El Niño, but also regional and national impacts, which is what we're going to focus on. The next one, please. To do this, there are different variations, but one of the main ones is interannual and seasonal variation caused by El Niño, and we're showing this now. now. The position and behaviors of the North Atlantic Oscillation, the other oscillation, and the Arctic Oscillation more recently. And I'm saying this because in this connection process, we can see all the phenomena that have to do with global warming. There is a growing outburst of polar vortices. And this means that we need to consider what's happening in the Pacific and how it affects the health of a country or region in the Caribbean. Given this scenario, Cuba has been working not just in research, but also in forecasting some indicators that can be several. There's the ONI, the modified ONI. We have worked with the May until the MEI, actually, May in Spanish. But actually, regarding a health sector project is very important. So we are working with the sector in order to guarantee synergies and better understanding. The ENO event, as such, has several impacts on our country. The next one, please. You need to consider that the same phenomenon during a warm stage or cold stage of the ENSO phenomenon, when there is a connection between atmosphere and ocean and the other indicators, this has different impacts on our country. And I don't want to overwhelm you, of course, so I'm going to focus on something else. I would like to focus on the final line. Nowadays, we are under La Niña conditions. It's a cold event, but that is modulated by the positions of the now. So this brings a change from what we classically expect from La Niña. And this echoes what my colleagues have said. Every El Niño, La Niña, ENSO has their own behavior, and it is now modulated regionally by other variation modes that can contrast and may require tailor-made forecasts. Then we developed complex indicators to integrate all this information. The next one, please. Here we have this index, the IB index, that includes all these conditions. We have radiation and other indicators. And this has been created specifically for the health sector, and it shows us how solid and tailor-made this climate service is. It allows us to describe the regions that will be more or less affected. For instance, have a look at December, our current month. We are now being affected in the west area, in blue on the first map. We are affected by drier, colder conditions, and this is very different from the Central East area. In one case, there are more respiratory diseases, and in the other case, there are more vector-borne diseases. And this agrees with the rainfall pattern. And on the right, we have different regions with more or less humidity. These conditions feed epidemiological models. The next one, please. And with this perspective, we can produce monthly and quarterly forecasts. This is January, April, not many rains, and the conditions that we need to expect that will favor or not the emergence of epidemics or an increase in infectious diseases. On this slide, we can see the expected impacts. we can clearly see that this is a TD group working together that includes virologists, clinicians, epidemiologists, climatologists, mathematicians, etc. And I don't want to overwhelm you with too many maps, but this table shows the expected impacts given this new short-term La Niña phenomenon modulated by the patterns I mentioned. There are other newsletters focusing on the other infections, but I wanted to share this one because I wanted to see how this has been done. And these are other climate services that help users. This is what needs to be done for people to understand. And it's important to disseminate this from the health center as well. So it's not just meteorology doing this. It's something that the health sector needs as well. And this is what is expected of climate services. Finally, some key takeaways regarding climate services. First of all, we think there will be a short-term La Niña event, and this agrees with what NOAA and the WMO say. And then we're going to transition quickly to neutral conditions. So we will be modulated by the other periods, as you can see on the screen. It's not just variability caused by El Niño, but also the other Arctic oscillation and QBO oscillations as well. There is also something that is not so typical, but we are expecting penetration from a cold air mass into the country with high frequency of the flow. This will cause a less humid and drier climate that will favor the emergence of respiratory diseases associated with germs and viruses such as influenza. And also, as something to consider, we need to remember how this helps or contributes. It doesn't mean that it will eliminate epidemics, but it's important to take action. And now I would like to focus on the final slide. We need to remember that forecasting and EWS are not useful when the problem is there already. Our lesson learned is that we need to focus on this, and this is one of the main challenges faced by the WMO now and by every scientific center. It's not enough with having good early warning systems. We need to train the population and train decision makers so that they take proactive decisions instead of reactive decisions, because from a scientific perspective, the forecast is correct, but the impacts grow, and also the associated costs. Without further ado, thank you so much for your attention, and we remain here. I am at your disposal in case you have any questions. Thank you.
Thank you so much, Paulo. Very important messages on the studies and the systems that we have. What we need is proactive early alert, especially when we still can have time to work on prevention. And the ability to work on prevention versus working on response is still something we need to work on. But at the level of some sectors, we do have made some progress, even though we still need to come out of that disaster management mode to prevention mode. And now I would like to invite Berny Fallas to share with us about one of the weather services that we didn't used to talk about so much, but we have very solid evidence of the work they have done. And this is about weather services and the energy sector. Welcome, Berny. Go ahead. Thank you so much. Rodney, thank you for this space to share the impact of these kinds of events on the electricity, on power. And in Costa Rica, we have mostly renewable energies. And part of this matrix has to do with hydroelectric power. For many years, we had almost 100% of the demand covered. So on this dependence on hydroelectric power, and then also we have wind and solar that have become more and more important. And so we are going to look at the impacts of El Niño on power generation. We have a decrease in rainfall, and so water flow in rivers, and we have an increase in the time of sun available and in winds. And so we need to look for alternatives within this matrix of renewable sources of energy. For La Niña, it's the reverse. We have an increase in rainfall, and we have a reduction of the resources involved in solar and wind energy. And we have a case study from El Niño 2023, because for the last 4 months of every year, they ask us how the weather the next year is going to be like. And so we had to forecast the conditions for 2023 in 2022, and even if we had a sign of what may happen after this. And you can see we had a high dispersion in forecasts. There wasn't a clear scenario. And we were on the tail of El Niño phenomena that had lasted for some years. And so what we did was look at history and of the data available so far. And we identified several years with long La Niña, and in the majority of the years following those, we moved on to the conditions of El Niño. And of course, that makes sense. Nature tries to find a balance, and the atmosphere has that mechanism, that warming up to try and get the ocean to a new balance. And so that made it reasonable to think we would go into warmer conditions. The limitations at the time were that we had a high dispersion in the forecasting tools, and so we weren't able to plan whether we needed to import energy or whether what to do with water reservoirs and plan the costs. And so this was a big challenge. And the considerations we had at the time was that we had a higher probability of El Niño for 2023. And we also gave the warning that we needed to adjust the power generation to the probability of a deficit in rainfall, and also thinking of record temperatures. And so we see those record values, and this also would involve an increase in the demand for power. And so in critical months like March and April, where we have higher temperatures, we have the driest months and the year. And so we need to see what we could do to address this higher demand. And so they took the decision to have monthly meetings with the management team to follow up on the conditions and the forecasts. This is something that we still do to this day. We have monthly meetings with the management team to tell them about the forecast for the next 7 days in the seasonal and sub-seasonal conditions, with to give some indications of what we may expect for the next few months or even years if we do have some information that may point to that. And this made it so that based on the conditions we already were observing for El Niño already in 2023, that had already started affecting us for the conditions of rainfall and the flow of water in those places where we have the dams. And so this, what happened was that what we had predicted ended up happening. We started having a deficit in rainfall and in water flow, and 2023 was the driest year on record for many of the basins. And so in 2024, we had really low levels of water. We had historically high temperatures. I can't remember, but about 70 or 80 record temperatures, which was really significant. And so this meant that the demand for power was so high. So we had record high demand because people were having air conditioning or fans or anything installed to face those higher temperatures. And so we had to work on a plan for rationing, but it ended up not being necessary with the activation of the protocol because the reservoirs were quite low, but fortunately rains started right at that time, so it wasn't necessary to ration power. And so with the ONI index or the RONI index, it's something that it's really important to have an official determination so that the countries in the region don't have disparities, and also not having to depend on definitions from or decisions from different countries. So having unified criteria for Central America would be really useful. We are currently looking at having for the next year some assessments of forecasting systems with using AI, trying to find systems that will give us a higher level of confidence after 6 months, because we do have needs for those longer terms predictions. Also, we need to strengthen the technical teams. We were able to hire about 33 people, half of them being professionals, and half of them are technical workers that work in maintenance of the grid. And we also need to install some generation sites for those parts of the country where the natural conditions have not been taken advantage of yet. And so we have a plan to scale up generation, mostly for wind and solar, to be able to complement hydroelectric power, because when it's a really good complement, because when hydroelectric increases or grows, the others go down, and when hydroelectric goes down, the other to have a better output. And this is something we wouldn't have been able to do without the contribution from academia. These are some of the papers used showing the variability in the conditions here in Costa Rica, and also some things we have generated and tested internally about the effect and the impacts on power generation in Costa Rica. And that was my presentation. Thank you. Thank you, Bernie. I think you brought up some really interesting points about the significance for the sector and how you work on that. And this is relevant for everyone who works in weather forecasting. And what is going to happen with the ONI or the RONI, and for how important it is for countries that have the experience and already understand the dynamics of El Niño, and how each country and region has worked on that, the need to have a regional definition or sub-regional definition of El Niño is a challenge we still have, and all of the regions in Latin America and the Caribbean already have the expertise to take that step. So the ONI is about to be discontinued. So it's important to look at this new definition of the index. And we at the WMO are going to coordinate with the whole weather community in the region to discuss the implications and also what this index involves, so that you can have all the information available so that you can make any necessary reflections or decisions. Thank you so much, Berny. Thank you to all our speakers for today. In this second panel, the Sectoral Climate Services, and considering how busy the month of December usually is, having over 430 people during this webinar makes us very happy, and it shows how all of the member countries of our institutions are interested in this. And I would like to invite Dr. Anna Stewart to close this webinar. Thank you so much, Rodney. Thank you again to all the speakers for sharing your experience. We know that there is a lot of knowledge in the Americas, and our purpose is always to elevate the knowledge for the good of the region and the world. And I would like to close with this call to continue to build these connections between sectors, between different sectors and science. You mentioned healthcare, water management, energy, tourism. We have really good examples in the Americas where these connections, these alliances are working well, because these collaborations, like co-designing services, will help us improve the well-being of our populations, which is one of our goals. And so thank you. If you have recommendations for any next webinars, let us know. We would like to continue looking for platforms to continue growing this community that has so much to. Thank you so much.